I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life. A bonus edition.
Yay, I love bonuses.
Yeah, it's a bonus time. It's a question and response time. All those times we tell you guys, hey, send a question to us. A lot of those end up here where we get to listen to some of your chemistry questions, some of your non-chemistry questions, make some corrections sometimes, just hear interesting thoughts from you guys. So welcome.
Yeah, welcome. We're happy to have you here.
And I wanted to start off with a question not in our document, Melissa.
Uh-oh.
Throw a curveball your way. As you know, I was recently in the state of Indiana.
Yes.
It's a fifth state of matter. And I was there and talking about the recent episode we had about hydrogen peroxide with some of my family members. And my sister-in-law asked the question, I basically summarized the episode for them. And she asked, so what do we do about the fact that hydrogen peroxide is in pretty much like every toothpaste? And what do we do about that with kind of being concerned about how much we use hydrogen peroxide based on the results of that episode?
That's a good question. Well, first of all, I didn't really realize that there was hydrogen peroxide in toothpaste. I wonder if that's a whitening agent because it bleaches things.
Mm-hmm.
So that's interesting. But I will say the reason I first looked into hydrogen peroxide in wound care is because a long time ago, before my mom passed away, she had asked me about hydrogen peroxide because one of her patients, which it was kind of unrelated, she did hand therapy, but her patient was talking about something else, that she had been told to use hydrogen peroxide as a mouthwash, but then later was told it could cause cancer.
Yeah.
And so her patient was talking to her about that and asked if I might know about it. So I think that actually would be worth a whole other episode. But also, there's fluoride in toothpaste, and fluoride can also generate radicals in the right scenario. So I wonder if the radicals that the hydrogen peroxide form is likely to meet up with the radical that the fluoride forms and connect and sort of terminate and cancel each other out. So that's
Got it.
I think all that could be possible. I definitely think it's worth doing a whole episode on.
Got it.
At some point in the future. So that's on deck, but just not currently. I think it's going to be a big episode. And always when we talk about stuff with implications for people's health, I try to be really careful.
Yeah.
So I want to give that the time that it deserves. And I don't have a ton of time right now.
Yeah. One thing I wondered about that I said out loud to them, but also gave the caveat that I don't know what I'm talking about. Where I was like, it does seem like slightly different things to be like, do I pour this on my open wound or do I have this as one of several ingredients in my toothpaste on my teeth? And so I thought that there could be some difference there. And I basically tried to say that as like a way of being like, I still think it's worth it not to use hydrogen peroxide on your wounds.
Well, yeah. And if you don't have an open wound in your mouth, it's not going to cause like the wound healing issue interference that we were worried about.
Right. Yeah.
But it could still do bad things because gums are soft tissue membranes, and those are the ones that are most likely to be hurt by things is when you have those.
Right.
Your skin is a solid barrier, but there's not a solid barrier on your gums, if that makes sense.
Yeah. Okay, yeah, that makes sense.
Yeah, thanks for asking that question. Was that Allie?
No, it's technically, a combination of my mother-in-law, Barb, and my sister-in-law, Allie. So,
hi, Allie and Barb. Thanks for your question. That was fun.
There is a high chance that Barb will listen to this. She tries to keep up with the podcast.
I love her so much. So, hi, Barb, whenever you get here.
So, back onto sort of our like more actual list of questions we have written down. The next question is from Mason, a guy I'm pretty sure you know. And he asked, would being in different types of drinks like soda, diet soda, beer, or whatever change how the explosion of a shaken drink would happen?
Yes. So actually, that's a really good question. That's why I included it, because he actually asked me and I said, I guess you'll have to listen to next week's Q&R.
Nice.
But I liked it because different types of drinks will have different intermolecular forces. So if it's just carbonated water, it could act differently than carbonated soda. Or we talked about in the Mentos episode, diet soda has, I think it was less surface tension or something. So that's why it works the best with Mentos.
Mm.
So different solvents that your bubbles are dissolved in are going to have different intermolecular forces. So they'll be able to more easily or less easily explode when shaken.
Mm.
And also different things have different amounts of carbonation. So, beer maybe has a little bit of carbonation, but I think champagne, for example, has a lot of carbonation, or Dr. Pepper and Coke have different levels of carbonation. So then there would be different amounts of gas to be released, if that makes sense.
Right. And you don't have to forever ago about how Spindrift, for instance, has like a lot less carbonation than the average seltzer water or whatever.
Mm-hmm.
And so, yeah, it's like intentionally done sometimes.
Yeah, like a can of Topo Chico versus a can of Spindrift. I think one would explode a lot more than the other.
Yeah, yeah. Interesting.
Good question, Mason.
This next one kind of relates and is a cool note we got from a listener named Avishai, I want to say. And
I think so.
If I'm mispronouncing that, I'm very sorry. Avishai wrote this email to us. Hi, Melissa and Jam. I was listening to the Mentos episode and I wanted to add some things. First, you said there must be a bubble scientist. Well, there was a physicist named Joseph Plateau who wrote the mathematical laws describing soap, films, and hence bubbles. Second, I'm currently doing theoretical research into biological membranes, which are surfactants. The equations governing their equations are similar to those of soap films. So I'm kind of a bubble scientist. Best regards, Avishai.
I love this because I knew there had to be a bubble chemist somewhere, because there are people who study the interface of surfaces.
Uh-huh.
And when he said surfactants, those are actually things usually that can go between polar and non-polar things, so similar to soap.
Ah.
So that is pretty cool. So thanks for reaching out and sharing that. And it also goes really well with our last week's episode about bubbles in soda. So maybe Avishai would also have more to add about that.
Yeah, yeah.
And they also sent a little PS that I really wanted to include because we haven't had the opportunity to do many chemistry at home experiments lately because it's just been so hectic.
Right, right.
That we decided to put those on hold for a little while. But Avishai said, I also forgot to tell you of a cool experiment I've done with my kids. You fill a cup of carbonated water and throw inside some raisins. The CO2 uses the raisins as a nucleation site, so that's where the bubbles can meet up together, like the rebellion leaders in the last episode that we talked about.
Yeah, yeah.
And then the raisins rise up to the surface of the cup where the bubbles pop and then the raisins sink. And then the cycle starts again. So essentially the raisins have the intermolecular force between the raisins and the CO2 gas makes it to where the CO2, as it collects on the raisin, can actually lift the raisin up to the top of the cup.
Nice.
So that is a really fun, I've done that experiment with some kids that I know.
Nice.
Who I really love, and they were so excited about it. But it literally looks like the raisins are kind of dancing or floating. It's very fun.
When I read that email too, I was like, oh man, I really wish we had some raisins handy. Like I immediately wanted to do it myself. We have carbonated water handy like all the time here. So I was like, I could so easily do that, but I just don't have any raisins. So
yeah, I
was bummed about that.
You might be able to do something similar, but raisins are really good because I think they have a high surface area. So, and they're pretty light.
Yeah.
So maybe you could try something like a bean, like maybe try a coffee bean and see if it works.
Yeah. I wonder if they, depending on the coffee bean, I think some things might want to float depending on their density, right? And so that might be problematic. So maybe it's that raisins have high surface area and are dense enough to sink unless they have the bubbles, something like that.
Yes, exactly. You have to get all three of those things. And that would be a fun thing to do with your kids who are older. Like, why do you think this one floats? This one goes up and down, and this one just stays at the bottom, kind of thing. Okay, so the next one I actually want to read. This is from someone who goes by Nerd Hobbyist on Instagram.
Okay.
And I wanted to read it because there's a few things that I want to add because I think the email is written more to a scientist and less to the general public.
Okay.
So this person said, hi, I started listening to your podcast in order and just now listened to an episode from October of 2019. What even is sunscreen and how does it screen the sun? That one's from a while ago.
Yeah, that really is. I was like,
I think
our first 4 or 5 months or so.
Yeah, definitely. I think we started in August, and that was October.
Yeah.
Okay, so they said, I know the episode was several years ago, but there's something really cool about titanium dioxide, a common active ingredient you guys discussed. It's also a pigment used in a ton of acrylic paints, and the pigment that most artists use in the color titanium white because it's inorganic. And so I want to break in here and say inorganic means has a metal in it, but it's also not carbon containing.
Okay.
So it's inorganic, which makes it more opaque and more stable. Organic pigments, so that means, I'm going to break in again and say that means carbon containing pigments. And that's what I worked with more in my research when I was in organic chemistry lab. So they said organic pigments are a little bit trickier to emulsify, which means to evenly dissolve throughout the solvent. That was my addition again, and work with. So essentially, they said that inorganic solvents are easier to mix in than organic pigments. And then they finish off by saying, I just thought it was amazing that our most common sunscreen ingredient is a popular pigment in the art world and wanted to share.
That's interesting. I had zero idea about that. That is such a cool fun fact / tidbit / chemistry bit of knowledge. I don't know.
Yeah, that is really cool. And I think I maybe saw that somewhere and wondered, is that why sunscreen is white? But I didn't really think much about it. I just kind of moved on. So I would be kind of curious if that's true.
Yeah. Interesting.
So thanks for reaching out, Nerd Hobbyist, for sharing your art and chemistry nerd alignment. I love it when that happens.
This next question is from Gavin S. And Gavin asks, hi, Melissa and Jam. I have a question about thermal receipt paper. This is a little while ago, not super long ago, but probably in the fall, I guess, sometime. We talked about this. I've always liked playing with it to impress my friends by writing on it without a pen or using a lighter to heat it up and watch it look like ink is drying. But I never really understood how it worked. I was wondering if you could possibly do an episode on this paper and why it works the way it does.
So that's a really good question, Gavin. And actually, I think it would require a whole episode to fully address it. But we did talk some about thermal paper and BPA and other similar molecules, so you probably shouldn't be using them to just play with. But also, it's very similar to the way that color changing mugs work. So when you apply heat or pressure, it changes the equilibrium. And I think it's pressure too, not just heat. But when that happens, it changes the equilibrium and the color changes. So if you need a very similar answer to kind of satiate your curiosity until we put this fully together, you can go back and listen to the episode on why do color changing mugs change color.
Nice.
And they're very, very similar, but I will try to bring a full on episode together to help you out with that.
Nice. That's a great question. This next message is from our friend, Mr. Hollis, who's a super cool chemistry teacher up in Illinois. And he writes in cool stuff and uses our podcast sometimes with his class. And that's been super cool to get to know him a little bit. So he wrote this message in reference to careers in chemistry, which we've talked about multiple times in Q&Rs. So here's what he said. I became a chem ed major because I wanted to coach football. The first day I volunteered on the football field, I knew that's what I wanted to do the rest of my life. But before that, he was a marketing major. However, I ended up interning at Caterpillar's Technical Center doing research in lubrication, friction, and wear. I was doing some fairly involved stuff, and they offered to send me to grad school. But those 2 years in the lab let me know that is not what I wanted. Nor did I want to go into pharmaceutical sales, like some of my classmates, even though I would have made an absolute pile of money. For me,
that's true. Pharmaceutical sales and actually sales in general, you can like sell chemicals and stuff. You can make a pile of money, and having a chemistry degree does help with that.
Nice. So then he continued, for me, the classroom was where I wanted to be. It's where I was meant to be. My brother-in-law has an accounting and law degree and works in patent law. He actually works in pharmaceutical patent law and has become a fairly adept chemistry communicator. You're right. Those people make lots and lots of money.
Yeah. So I think that those that was helpful because it kind of gave insight into you can get a chemistry degree and not want to work in the lab, just like we talked about in the previous Q&R. But there are options like being in pharmaceutical sales, being a teacher, and being in patent law. So there's lots of other options, but it is really important to do what makes you happy. So even if a pile of money is on the table, be sure to take the thing that's better for you. Thanks, Mr. Hollis.
This next question is from Grace L. And Grace asks, what school do you teach at?
Well, Jam, what school do you teach at?
Oh, Melissa. I almost fell for that. Oldest trick in the book. I almost said what school I teach at, even though I don't teach anywhere.
Well, okay, I just thought it was funny. But Grace, I teach at the University of North Texas, at least for right now. I'm a teaching fellow. And this semester, I'm a teaching assistant to lower down some of my responsibilities. But I am most likely going to work somewhere new starting in the fall once I graduate and get a job. So that's kind of exciting. So I'll keep you posted on that as it happens.
Nice. This next question is from Ashley, and she said, who's your favorite woman scientist since it is Women's History Month this month?
Ooh, that's a good question. I don't think I actually have one off the top of my head. I feel like I should. But I have a lot of women scientists in my life who have encouraged me. But I will say, when I watched the movie Hidden Figures, that really was powerful and impacted me to think about. It feels sometimes like I have a lot of barriers up as a woman in science. But thinking about how much the intersection of identities and having to deal with other biases, not just against being a woman, but also being a woman of color in science really, really impacted me. So, but also right now, I think my favorite woman scientist that I'm learning from is Robin Wall Kimmerer, who's a Native American botanist. I believe her PhD it's either botany or ecology. And she wrote a book called Braiding Sweetgrass about, we've talked about this idea before, but about how the Western way of knowing is not the only way of knowing.
Yeah.
And she does a really good job of bringing together indigenous knowledge with Western science. And it's really, really beautiful. And that's sort of like current, but it also is about some of the history of America and its people. So I think that's really beautiful.
Yeah. Dude, that's cool.
What about you? Do you have a favorite woman scientist?
I know so few scientists in general. Like, I wish I just knew more, like by name or something. You know what I mean? I'm sure that if I looked behind some discoveries, I guess, that I've cared about, or some research I care about, I might be able to find some and it'd be that route. But it's not common for me, unless it's somebody you've talked about, for me to know a specific scientist.
Yeah, I also think I have a book on women in STEM that's got lots of really cool women in science, but it's hard to think, oh, this person's my favorite, or to not just go for like, oh, Marie Curie.
I know.
She did some really amazing stuff. And I also think maybe a lot of women in science had their discoveries and contributions taken credit for by men. So it is hard to know and to keep up with. But yeah, so I forgive you for not having a favorite woman scientist. You can just say I'm your favorite.
I will say that, like, I think the stories of specifically chemists that I remember hearing about, Marie Curie, I think is the one I remember the most about. Like some of the other dudes' names and stuff, like maybe I did hear their stories, I can't remember. But I do remember learning about her and feeling like, impressed and very interested in her story and what she's contributed to chemistry. So I feel like that's an easy one, but certainly still a cool one. It's not like it's so,
it doesn't count.
Yeah, exactly. So I think the average person, if they don't know much about her, would probably be pretty interested in what she's done. But yeah.
I really wanted to watch that movie that came out. I think it was on Amazon, but I never did.
Me neither. I just thought I was thinking about that. I remember watching one, probably because of a chemistry class or whatever, toward the end of a year. And it was an older movie about Marie Curie. And the fact that there's an updated one, I thought was super cool. And the main actress in it is really good, whose name I can't remember. But I haven't seen it yet either. So we should do that at some point.
That'd be a good hangout night. One day after your kid's in bed and we're just kind of chilling.
Yeah.
That'd be good.
Yeah, definitely. We'd have to just convince our respective spouses to be also interested, which I think they would be.
I think they would. I think they both would be interested enough in that.
This next question's from Renee C., frequent question asker and frequent sister of Melissa.
Not always, just frequent.
Yeah, just frequent. Most of the time. So she asked, what is your go-to book recommendation right now?
Well, I kind of scooped myself because I already gave away what I'm reading in the previous question. But I do really, really love that book. I strongly recommend it. I think that is a book that makes scientists reflect on the pride that we all often have in knowing so much.
Yeah.
And it reminds us that we need to reflect on what we don't know and what benefits there are from other ways of knowing. Similarly, a book called Isaac's Storm made me feel that way about the pride of meteorology and how they underestimated what nature could do.
Yeah.
But I'll give a lighthearted recommendation. I needed a bedtime book, so I started reading a little cozy mystery called Arsenic in Adobo.
Uh-huh.
And it's just it reminds me of Murder, She Wrote, but just in a book, It's like one episode of Murder, She Wrote. Everything's going to get wrapped up and solved, and it's not too graphic, and there's lots of like good food descriptions and fun with her family. And so,
Yeah.
it's a good book to read when I'm going to bed instead of scrolling TikTok.
Nice.
So that's my other book recommendation right now. But Braiding Sweetgrass, 5 stars. Highly recommend. What about you, Jim?
Okay, so this is a tough question. I read a lot of nonfiction. I don't read a lot of fiction stuff, and I don't recommend a lot. There's occasionally times where it's like someone has a specific thing they're talking about, and I'm like, oh, I read a book that has to do with what's happening in your life right now. But I don't really have like just one book that I'm trying to get everyone to read. Does that make sense?
Yeah, totally makes sense.
So, but I will say in the fall, I read the graphic novel Watchmen, finally, and it's super good. And I have recommended it quite a bit, actually, just not to everyone everywhere. But that graphic novel is it delivered on the hype for me. And I don't read a lot of fiction at all, and I don't read a lot of graphic novels either. So that's coming from a guy who kind of didn't expect he'd like it, if that makes sense.
Yeah, totally.
Yeah.
I actually am in a group of ChemEd grad students, like other people in similar programs to mine across the country.
Uh-huh.
And we talked about what we were reading. And a lot of people said, I don't know why I've avoided graphic novels for a really long time, but they are a really beautiful way of combining art and story.
Mm-hmm.
And I love graphic novels now. So I like that recommendation. I think that's a good one.
Yeah. And it's a really unique and cool art form and story form. I kind of get it now too. I don't know how I missed it for such a long time, but yeah, very, very cool.
So that's a good one. All right. Well, thanks to all of you who wrote in questions. We really appreciate it. And we'll be back next week with a brand new episode.
This episode of Chemistry for Life was created by Melissa Collini and Jam Robinson. I would like to give a special thanks to E. Robinson, who reviewed this episode.